This is the Waves of Innovation podcast, which is all about adopting and adapting to the use of AI in the workplace. I am your host, DJ, and in this episode, I am talking to Amy Heineike, who is founding AI engineer at a company called Tessl. We talk about the stuff that Tessl does in order to reduce the likelihood of hallucination in coding agents. We talk about how to evaluate whether agents are doing the right thing and how evals differ from traditional testing. We talk about the importance of good product management when you're working on an agentic system. And then we kind of go philosophical about all the ways that coding agents might impact software development in general. Hopefully you enjoy our chat. I know I did. Amy Heineike, founding AI engineer at Tessl. It's great to have you with us. What are you and the folks at Tessl doing at the moment?
Hi, Daniel. It's great to be here. Yeah, so we are building tools to help people who are using coding agents every day. So we've released a registry of documentation for open source libraries, and we publish some cool evals on those to show that it makes the agents work a lot better. So hallucinate APIs less and use libraries as they should be, which is cool. And then we've got increasing amounts of tools for people, so especially maybe in enterprises who are trying to figure out how to roll out their agents and make them work better. So adding documentation for your own repos, other stuff that we'll be releasing soon.
The avoiding hallucinations when you're coding to other people's APIs is definitely a useful one, because the most frustrating thing is that models seem to hallucinate things that it would be really great if they did exist, but they don't. And then when you find out they don't, not only have you wasted that time, but you're also really disappointed.
Yeah, you're really disappointed. I think, they kind of tell you what they wish the right answer would be. So my job at Tessl, so I'm on our research team. And so I spend time trying to work out what on earth agents are doing. So I've built up a lot of our eval tooling so we can measure what they're doing, measure what they do under different conditions. So if we give them better documentation or not, for example. And then I'm also prototyping some new ideas that feed into kind of our future looking kind of planning and ideas. So I get to kind of tinker with different ways of using agents and checking if that makes them better or not.
Awesome. So that means you get to do all the exciting top secret source stuff, because it's such a fast moving area that I should imagine you're like sticking your flag in the ground of this is our product, this is the only thing we're ever going to do. It's probably not a sensible strategy this early in the AI revolution.
Yeah, and I think Tessl's fairly early still in its journey. So we're still very focused on learning quickly. But yeah, as you said, the space is moving so fast. It's completely wild. And I think everyone of us who's working in the space, I feel like every 2 months you have like a major revelation where you're like, oh, wait, now I can rethink how I do everything. I've just been realizing how incredible skills are as a way of packaging up software, playing with that a load. But yeah, it's totally crazy. And I think in a way, I think we're quite lucky being in a small startup because we can just go full hog into everything. So if there's a cool thing that's starting, we dive into it feet first and just try it. So we don't have too much legacy that we need to kind of be careful of. And so I think we're taking on some of that experimentation, because we then know when we talk to people who are doing this in kind of big serious companies where they've got like a lot of legacy or a lot of very high stakes software that they're working with, that they're also wrestling with the speed of change and worrying about what they should use, what they shouldn't, and how to reason about that.
Yeah, and that just on the subject of the folks in big enterprises who are like the people in most need of these tools and this assistance, they're the ones with the least amount of time to experiment because they're under feature pressure. So it's great having, startups that are dedicated to exploring this space to do that work. Otherwise, it would just be like the odd engineer in an enterprise on a Sunday afternoon taking some extra time to kind of to look at things. With the so with the kind of main Tessl product, I think the Tessl tool as it stands at the moment, would you be able to like describe what that does, and then maybe from there we can kind of segue into the why evals are important for you folks and to get the most out of the tool?
Yeah, absolutely. So you can install. We've got a CLI tool that you can install, and once you've got that in, install. Well, you can search for and you can install documentation very easily. And then there's an MCP server that you can start up so your agents can get documentation via our MCP tool, where we've got a really optimized way of reading the docs. So rather than like the agent having to read lots and lots and lots of text and stick it all into its context and kind of pollute it, it can go by this tool to get kind of summary versions. You can also tell the agents to just read the full docs if you want to. So that's the thing that you can just get going on at the moment. You can also go in, and if you've got your own repo, you can kind of connect that in and have it make documentation for repos that you're using internally. So there's a registry, basically, then you can have private registries on there that you can then start sharing documentation with your teammates safely. So yeah, one thing that we've realized is that when you're working, Git works great for all of our code. It's like a little bit painful for kind of documentation, markdown files that you just want to give to agents, because you often want to publish those in lots of different repos at the same time. You don't necessarily want to tie it to it's in one, and now I need to like create some mechanism for copying and pasting these files all the way around. And so it's quite helpful to have a separate kind of registry place where you can stick your markdown and then pull it in for different agents. So I've talked a bit about documentation. You can also do this with things like style guides and other kinds of instructions or ways of working that you want to share with your agent. We also have a spec-driven development tile that you can install. So this is basically documentation that will steer your agent to write detailed specs for any code that you're writing. And we've found that that often will help ground the agent a little bit more, so you can kind of write down your intent nicely and make sure that that's very clear, and then you'll get more predictable behavior when the agent goes off and starts writing code. But yeah, so again, this is a set of instructions you can install for your agents easily from this kind of command line tool that you can easily install. So yeah, so all of that is free, and then you can also contact us if you want to talk about other kind of tooling that you want to roll out internally within your org to kind of make it easier to get the agents working well for you.
Yeah, so it sounds like you folks are very much interested in figuring out what works for people, and open to new ideas. So with the Tessl registry, that's primarily around providing more of the right context to the model. So when you're asking to make a code change, the model has documentation or a summary of like the API that you're using. I can't quite remember where I saw it, but I read somewhere that the kind of sweet spot for hallucinations is anything since the model was trained. So anything that's not in the training set because it's too new, and anything that maybe is older than like 6 years or say, because that's going to be poorly represented in the training set. But any cutting edge APIs, if you want to use the latest version of a library, it's quite likely to hallucinate or give you like old versions, or it will think about old versions of APIs and method calls that no longer exist or have changed. And so you're kind of either you are not aware of that and you let it hallucinate, or the kind of best case, you tell it, oh, can you do a web search on the latest docs? Like, I want to use this library. Please go and check the docs and the API docs that this is actually a thing, which is a bit laborious and tedious. So the Tessl registry kind of takes the pain out of that and does that. Is it more of an automatic process behind the scenes that the agent and the model are kind of figuring out for themselves to make use of your tool to find the right context?
That's right. So we're running automated processes for publishing documentations tied to the version of the packages that you're using. So you can then manage which versions. So you have like a Tessl.json file that goes into your repo that kind of records which version of each of those tiles you want to have installed and ready to read. So so we can tie it up really closely. So as you said, I think part of the value is the fact that you're avoiding the kind of hallucinations. The other one is that sometimes we find agents are actually quite smart about, they'll go and like, as you said, they'll search the internet to read the docs, or they'll go through like node modules if you're doing something like TypeScript or JavaScript, and they'll like read the code base of the thing that they're trying to use. It's just not super efficient if you do that. So if you imagine that every time that you're trying to use a library, the agent is going off on this search to get to first principles of like, what is this doing? It just doesn't feel that efficient. So if we can do that once basically and turn that into docs, and then you can reuse that every time you need it, that seems a lot more efficient.
Yes, I'm just thinking about the kind of token usage of having your agent go and web pages these days. I've got some friends that are like old school web developers who are constantly complaining about web page bloat, but like trawling through all that HTML and probably multiple pages full of it and sending that backwards and forwards to a model going, can you pull the useful bits out of this, please? That doesn't sound like a good usage of tokens. And so with that tool, you've got your tooling, which is creating these documents, these kind of summaries, that tiles that represent different dependencies. But a lot of the kind of ability to deliver value to the user there is dependent on the agent and the model. So things you don't necessarily control. And so I guess that brings us on to evals and like, how do you folks figure out, like, when you've got different moving parts you're not in control of, like whether the things you're doing are having a positive impact, whether having a negative impact, whether someone's changed something outside your control and that's kind of derailing things for you?
Yeah. And so I should first of all say, this is the situation that we're all in, right? So when we're using coding agents, they're so powerful, but also they're changing in ways that are tricky to follow. And they're not always explicit about what they do. And we sometimes find that the docs that say how they work don't seem to totally line up with how they work anymore. So the pace that the labs are going at is incredible. Like, I mean, I think Claude Code has 3 releases a day or something. Or we've had major version updates within a month, and then the underlying models are switching all the time, and you can just use a picker and switch between them. And so you've got this interaction between the harnesses and the models. So I think this is what everybody is dealing with. And I think part of what we see the value that we can bring is magically saying that we're going to solve all of this, making it easy for people to understand what is going on. So like, I think if you're rolling this out to a team, you want to have some kind of view of what the hell is going on and where are the problems that you should be worried about, where are the problems you don't need to be worried about. The evals are really important. So what we can do, so the idea of an eval is you're going to set up like a synthetic scenarios. So we're going to write down a bunch of different scenarios, set up a list of them, and each one of them we're going to give a coding agent a task to do. There's a few different ways we can pick what those tasks are, depending on what type of problem we're trying to narrow down and understand. So we're going to give the agents a task to do. We're going to watch them do the task. We're going to gather their logs. We're going to gather what they did at the end. And then we're going to have measurements or the grading criteria that then measure, did they do what we asked? Then we can get a final score. So we can say in this scenario, this percentage of the time, it matched this score. And because we have a harness around it, we can run it multiple times. So we can measure a bit of the variance that we see. So how predictable it is. Because we have a range of scenarios, we can maybe look at, are there certain types of scenarios that the agents work better on, certain types that they don't work as well? But we can boil it all down to a score. So then you can look, if I add the documentation or I don't, how does the score change? If I change the model I'm using, how does the score change? If I change the agent I'm using, how does the score change? So each bit of that, the design of which scenarios do we use, how do we grade it, what kind of score is useful, we can hone that into the specific question that we're trying to answer. And so we've thought a lot about this. We could talk about this for hours, but generally that's the approach. So we have, these are the elements that we need to debate. What are the scenarios? How are we grading it? And then what are we scoring or comparing across?
It's just interesting that, I mean, that's quite different to what a lot of software developers are used to, of like hard logic, like either thing passes or it fails. And if everything passes, then we proceed to the next step. Where this is much more like the kind of thing that presumably data scientists do, of you're running experiments and you're looking at confidence and, the statistics involved and trying to find thresholds above which you believe that, like, if it works in this many percent of the time, then we're happy with that, which is both a different skill set, presumably, and also a slightly different mindset.
Yeah, that's such a good point. And I think it feels like this is one of the hardest things about moving into kind of agentic software development and into building products that have AI as a big component. Realizing that you're having to do this kind of this kind of cultural shift almost. So it feels less like engineering, feels a bit more like being a biological scientist or something. I think the reassuring thing is that, so in something like biological sciences where, where do you start? You start with a complicated beast that you're trying to understand. You don't start with small pieces that you build up. It's still possible to get a sense of understanding of what's happening, but it just looks very different. So I think, with unit tests, if you fix the unit test stays fixed, which is quite nice. But I think for eval cases, what you can find is what we can do is we can build up very granular measures of, in this scenario, does this thing work? But there's lots of things that might affect it. So it's not like if it sometimes fails, that's a bug that you can just go and correct. What we're looking for is getting a basket where we can say, okay, across this whole selection, what's the kind of average success, and can we make the average more effective, or can we characterize the things that the model is just not good at yet and the things that we can fix and improve? So yeah, it's very different. It's a different headspace to be in, and I think for a lot of people, having worked with agents, having worked with AI tools for a while, I think it's starting to percolate in where it's not quite so weird. You kind of get used to the idea that these models are a bit unpredictable, but it's a big shift.
Yeah, and it's just making me realize that maybe us software engineers, I probably don't get my hand on the code often enough to include myself as a software engineer, but just maybe we're the weird ones of everybody else has to deal with this,
Yeah.
non-determinism and having to look at averages. Because you were talking about biological sciences, and I was thinking it's also kind of the same for product managers. They don't get one this feature is definitely what the market wants. It's instead, we're seeing this metric go up and this one goes down. I think in this place it works and in that place it doesn't. So maybe software engineers have just kind of had it lucky that we've been able to determine things with such a degree of certainty. So the kind of tooling there, I think when we've chatted in the past, you've mentioned that you're building your own tooling. Is that right?
Yeah, that's right. So we keep looking at what tooling is out there. So there's some projects. There's one called Terminal Bench that we've found very useful that we're using pieces of. So, but we have built a lot of our own harnesses as well. Yeah.
So if they were building agents, so rather than using coding agents, but actually building an agent themselves, and we're trying to work out how to tell if it does the right thing most of the time, do you think that from what you've seen of the marketplace, the open source marketplace, there are kind of go-to libraries that you recommend, or is it still sort of being won out, do you think?
So it's a super good question, and I think it's moving so quickly that it's very hard.
That's a good point. It takes a couple of days to edit these, so by the time that it's edited, then it's probably going to be out of date anyway.
I think so. It's worth making the point that what we're grappling with is moving quickly too. So a year ago, if we were talking about evals, we would be talking about evaling individual model calls. And so we'd be thinking about having a set of example prompts that we feed to a model, and then we will grade the output of the model. So text in, text out. And the grading that we'd be doing for those output prompts would probably be a combination of LLM as a judge, so asking another model to say, does this match some criteria? Or maybe something like a similarity to a golden answer that we've written somewhere. Maybe there's some other deterministic check that maybe the answer includes certain words or something. So we'd be looking at a system like that. And I think those have gotten quite mature. So for example, you can just go use, inside the OpenAI platform, they've got a whole eval product where you can kind of capture traces and capture those inputs and outputs, and you can label them, you can mush them around. So there's ones inside the labs. There's ones I think Braintree is one that's popular. We've used a observability platform called Langfuse, which is open source, and that has built into it an evals thing where you can be monitoring traces, you can be capturing them, and then you can be putting them into a data set that you evaluate. So I think it's getting a lot more mature for this kind of individual prompts and then seeing what they do. We have moved up the tiers of difficulties when we start talking about agents. So agents, obviously, depending on what you mean when you say agent, we might be asking an agent to do multiple steps of reasoning. We might be giving it a bunch of tools. We might be giving it a load of different files. And it might be running for quite a long time. we might be interested in just what it does if you give it a prompt, you leave it on its own. We might be interested in what happens if you have a session where you start it running and then the user comes back to the user responds, you go back and forth. So, so this is level difficulty. We've jumped way up here. So we might have something that's long running, we might have something expensive, there might be different parts of it that we care about. So we are seeing more tools coming out around this. So so Terminal Bench I think is really cool. So they've released benchmarks. So they've built this harness where you can kind of brand big and different benchmarks where you're basically setting up an agent, you're giving it tasks to run in a terminal, and then you're marking what it does at the end. We've built internally some tools. So I've worked on one that we called AutoCloud for a while, which has been fun, where we have a simulated user as well as the coding agent. So you simulate the user, you tell it how you want it to talk to the agent, then you set up your agent, and then you have them chat to each other. And so it's super cool. So the simulated users tells the agent what to do, and then the agent has questions. It comes back to the simulated user, and the user responds. You watch them go back and forth, and then the user decides when the task is complete. And so that tickles the agents in very different ways. So we could give the agent an instruction to say, ask the user lots of questions before you start the task. So we need to be able to see if it does in fact ask questions before it does the task. And so we need to have this kind of automated user as part of the eval. And recently, Anthropic just released a tool, which I think was called Bloom, which was looking at very similar. So I think they have the simulated user in there, but looking for how well aligned an agent is with its overall steering. So does it do harmful things, and is it rude, or they might have these like good behavior kind of metrics that they kind of grade. So I think we'll see more tools that have that kind of thing built in. So if you're starting out wanting to grade what an agent is doing, the first thing is to think really carefully about what you want to measure and how focused you can be on just measuring that thing. And then you can work out what tooling. Can we simplify it all the way to you just looking at a prompt, in which case the tooling's really easy? Or do you want to kind of measure a system that might be more complicated? And then maybe if it's very custom, your whole system, maybe the best thing to do is to make your own harness to run it and use, little tools as part of that to make it easier.
It's interesting that like the degree of complexity explodes really. And when you think about like the interaction between just an agent and a model, and you're looking at that one prompt and whether you get the right thing back, that seems kind of within the realms of what a lot of folks are used to testing in certainly in enterprise software. And then when you go to the interaction, is the agent doing the right thing? Then that's another layer of complexity. But then the adding in the vagaries of what the user might end up doing, all of a sudden that reminds me of like testing in video games is somewhat hard, because the inputs and the response, though, certainly in the pre-AI world, that was very hard to automate. But you end up with things like people just doing weird and random stuff. I'm going to go off on a tangent now. I was lucky enough to do some work experience at a video games company called Codemasters, and I was in the testing department for a little while. And testing video games is nowhere near as much fun as you might think. It was great for me as a 15-year-old.
Yeah.
But we were playtesting Pete Sampras Tennis, I think, on the Mega Drive, a very old 16-bit game. And one of the testers was just like going mad, playing tennis constantly all day, every day for weeks on this console, and decided that in a fit of mania was just going to walk up to the umpire and constantly swing his bat at the umpire. Found a bug, and the game crashed, and presumably, some value overflowed or something like that. But how would you think to even test for that? So I think we're kind of in this world where you have an unbounded number of possible inputs, and the idea of protecting against all of them is
absolutely. And I think there's two ways I think about that. So one of them is, if you can learn, like maybe we want to learn some principles that we can kind of apply and understand. So one thing that we noticed that was very interesting was, so if you give an agent a bunch of instructions, like system prompt kind of instructions, like your cursor rules or your Claude.md or something, if you put a lot of instructions in there, if you then ask the model to do a task and you just give it a very brief description of the task, it will tend to follow all of the instructions. But if you give it a really detailed discussion of the task that you want to do, it will tend to ignore most of the instructions.
Which is
And
kind of the opposite of what you want. You're going to the
oh,
effort of like...
because the good behavior is to give the detailed task instructions. But when you're doing that, I think in a way for agents, I think that one of the key tasks of an agent is weighing its context and deciding what to kind of ignore and what to put weight on. And so you kind of want the agent to be making these decisions, right? Being like, oh, if the user was very prescriptive about this task, probably that's more important than thinking really hard about all of these other kind of rules they gave me, maybe, but it makes it very tough. Yeah. So the first thing is if there are a few of these principles that you're kind of aware of, that can kind of help you reason a little bit about what's going on. I think the second thing ties into observability a little bit. So I think it's a really great call out you made about this being a bit like product management world, right? And realizing that users can do all kinds of crazy stuff, and you give them an AI interface and they can do all kinds of crazy stuff. And I think, in the ideal world, you are tracking, you have some observability over what is actually important to your users, what they're trying to do. And then you can see how agents are responding to them. You can kind of watch that flow. And then you can go and dig into that and discover where is it going well for people and where is it not going well for people. And those are the things that you anchor on. So you don't worry about every edge case in the world because you can't possibly map it all. But you can think about what are the kinds of behaviors that we care about. And in those behaviors is the whole thing doing what we wanted. I do think, and I think we might have talked about this before, there is this interesting thing where in that case, building the eval doesn't feel like this kind of separate technical task. It feels like defining the product. And so it feels like a task that, you want to have this kind of product design hat on, where you're thinking, what are the behaviors that we care about? What are the expectations? And it's almost like in the past, maybe we used to spec out kind of user journeys and you could show the pages on the website and, user clicks here, they click here and they click here. And then this should all be smooth. Or maybe your QA team is going to check that all works. And now we're encapsulating a similar thing as kind of an eval. If a user comes in and asks this kind of question and they're in this kind of state, here are some expectations around what a good outcome for them would look like. And then if we can capture that as an eval scenario, then we can start measuring, is that happening for them? Or maybe we can measure that in logs and observability. Is that thing happening to our users generally? And then we can know that this is something that we can worry about. Like if it's not happening, does that mean we need better models in the loop? Does it mean we need better guardrails? Does it mean we need to change the user experience because we are making life far too hard for the agent? So maybe if we ask the user to put more information in, it would give them a better outcome or something, but we need to worry about it. You're kind of flinging back into product land, then design land. I think, challenges to some extent how our teams often work and how we expect to have different groups of people in different rooms. And what tasks people expect, because suddenly you've got this task to do that doesn't feel like normal product management, right? But it's actually a very big control lever over what your experience will be like.
Yeah, there's so many interesting things to unpack there. First off, before I forget, eval-driven development. If somebody hasn't coined the term, quickly get the Tessl trademark people onto that nice and quickly. And you use the word outcome, and I think that's one of the fundamental challenges I've faced when working with kind of organizations and trying to help them be more effective and doing transformation of organizations is getting them to focus on outcomes rather than deliverables. Like, what do you want to actually happen? What is the change you want to see in the world? Not what is the feature you want to deliver? And, maybe if we kind of zoomed out a little bit to thinking evals first of what is a good outcome here, rather than the specifics of the journey, then that would help people focus more on delivering value rather than delivering features. And you also mentioned the fact that there's a kind of a rejigging of responsibilities. And when we look at how AI is adopted in organizations, whenever any change comes in, the first thing people do, quite understandably, is they want to use the new technology within the boxes on the org chart. Like, we're not going to change anyone's roles. We're not going to change any interactions between units in the organization. We're just going to use the new tech inside this box. And then slowly, boxes start to merge and people shift between them. And maybe with, all the crazy stuff that's happening with things like Gastown and agent factories and being able to give a whole product requirements documents to a set of agents, have them fully implemented. And at the same time, you've got product managers who can, just do stuff in Lovable without having to involve engineers. Maybe all of these functions that used to be separate are going to kind of coalesce into some sort of product engineer outcome focused person who's going to be thinking about what are we actually trying to achieve here for users? What would a good outcome look like? And then I'm going to use tooling to achieve that, or whether it's, I'm going to get Claude Code to do it, or whether I'm going to use, a low code, no code prototyping tool. It feels like there's an opportunity there for things to shift and boxes to merge.
Yeah, absolutely. So yeah, maybe smaller teams that have kind of these mixed skill sets as people are kind of learning them, be able to ship a lot more together. So you're changing the length of the iteration loop and who the iteration goes through. Yeah, that's really such a good point.
It's an exciting time to be in software development.
It's really crazy. It's super crazy. And I think, so thinking about outcomes. So I think I think outcomes are really hard, aren't they? And what struck me, so I've been working in machine learning for a very long time.
Since before it was cool.
But way before it was cool. I remember having a job. So I trained as a mathematician. I remember my first startup role was 2008. And I remember there being the recruiter. I think she forgot I could overhear her while she was on a call. She mentioned, oh yeah, we've got a mathematician on the team. We don't know why. I don't know what they're doing here, but yeah, so before data science was even coined. So yeah, very long time. I think in this time, I've gotten to work with enterprises who are going to use AI to automate something in all the generations of it. The hardest thing about automation is realizing that you need to be precise about what you're doing. And I think what you realize is that there's a lot of business processes where we're not very precise about what we're doing. And we're relying on people being given conflicting instructions and just doing something. And so we used to measure, we had some tasks where we had to label documents and say which ones were a certain type that needed to get flagged. And we'd have experts from the enterprise go label the documents, and they would label them. The inter-annotator agreement we would measure, and it'd be less than 50%, which I think means that they actively had different definitions in their mind. They were actively labeling the documents a completely different way. So I think a lot of businesses, it's very hard to know exactly what you're doing. And there's a lot of ambiguity there, and people are kind of fiddling on, fudging their way through. As soon as you kind of automate a chunk of this, it's a bit scary because you're encoding this into a system that maybe it's not deterministic, but it's maybe principled, where it's going to then be repetitive in some way. And so you want to be really careful about it. And in a way, it's good, right? We're saying a load of the busy work we are going to push to the agents, but we're going to have to spend more time grappling with what are these outcomes? How do we define them? And maybe because we're going to be able to measure them more precisely, maybe more of our lives is going to be at this level of defining outcomes, making them so, and then realizing you get what you asked for. Maybe that's not quite what we meant. And then iterating on these outcomes. So defining them, measuring them, updating them, rolling them out, changing them, seeing if that feels better, and that kind of loop. There's something very interesting there. I think as well, what's kind of nice on the outcome side is because we also have agents that can help us do evaluating the outcomes, we don't have to be super precise. We can use agents, models as judges, looking at text and outputs and agent traces and coding things, and they can measure things that were hard to automate before. So coding style, for example, we've had linting rules forever, but you can measure if coding style is followed in code, if that's something you care about, but in a softer way than we used to be able to do. So yeah, so we're going to put our heads into this outcomes world, and we can measure things that we didn't used to be able to measure.
And maybe that
we need to be iterating on those as we watch them roll out.
Maybe that desire for precision has always been misguided. So when you were explaining there about the agreement levels between different evaluators being less than 50%, it reminds me a little bit of, before we started recording, we were chatting a little bit about Gastown, which for listeners who are unfamiliar with it, Steve Yegg's new agent factory, agent orchestration framework that is completely bonkers. It's got all the most ridiculous names in the world, but can achieve a great amount of work by having lots of agents spinning up, trying different tasks, having different responsibilities, And occasionally they do the wrong thing, and occasionally they need kicking, and occasionally the work needs to be redone. Similarly, with Jeff Huntley's cursed language, where he coined the term Ralph Wiggum loop of having Claude code in a loop for 3 months, trying to implement a new programming language in a compiler. The reason that those things have worked is because of the non-determinism. If they were deterministic, there is a chance they would code themselves into a corner that they couldn't be nudged out of. And in the Ralph Wiggum loop, although I remember reading that Jeff saw it kind of get stuck for a number of hours, it would eventually nudge itself out of that local maxima. And so I wonder if the fact that in human systems and businesses that operate well, there is some amount of variability and diversity of like how decisions are made and whether people do the right thing or not.
Yeah.
Maybe that's a feature of of anti-fragility in things generally working most of the time. And then when you compare that to like, I don't know, a business process system where, okay, we're going to change the rules. And if it breaks for everyone 100% of the time. So, production outage, quick, we got to go and fix that. Maybe we just need to recognize that trying to get everything working 100% of the time exactly the same way is not a feature of biological systems or human systems or complex systems. And we just need to become more accustomed to that. And it would be interesting to see whether, like with the gas towns and the Ralph Wiggum loops, whether like what we're seeing is that being proven kind of experimentally that the non-deterministic means are the way to achieve largely consistent outcomes. Sorry, I've gone on a complete philosophical tangent there.
Love it. It's so good. Yeah. And I think, when you look at like the large scale social systems that we've kind of invented, well, not invented, but we're part of. So you look at something like evolution, you look at something like capitalism, like market economies, maybe. Sometimes it's these systems where there's a bunch of try things and then the thing that seems to be working you pile onto that work quite well. It's like genetic algorithms back in the day. I don't know if you ever tried those out. So this idea, you kind of randomly modify an algorithm and then you pick whichever one's kind of working better, and then you randomly modify that, you pick whichever version works better, and you just evolve an algorithm and then surprisingly effective way of creating effective algorithms. So yeah, I love it. Like embrace a bit of the chaos. I think there's another piece here as well where I think maybe we don't know what makes humans so great. And we like to think of ourselves as these rational beings that are, careful and thoughtful. And it comes back to some kind of first principles. And then you realize when you try and build systems that actually sometimes that wasn't what was making us great at all. You realize that the bar that you were trying to meet is in a completely different place than you realize. Like maybe it's much easier to kind of replicate some human behavior than you thought possible. Like, it feels like the bar is way lower, but then somehow the system is more stable. And so the bar is way higher than you thought in a different way. So here, some of this is grappling with this kind of what is good behavior. And yes, to your point, maybe not rule following is a big part of it.
I'm thinking back to my teenage self, and not rule following was the thing I was particularly good at, as any of my sixth form teachers for that very short period before I got asked to leave would attest to. I mean, just continuing to think philosophically, one of the things I find fascinating is I think we're learning more about ourselves with this fairly limited form of AI. I two things. One, I realized that I often dream about reading, and I have been dreaming lucidly enough to realize that basically my brain's just doing exactly what an LLM does, of like imagining sentences one word after the other, but kind of more applicably to agents and software development. There are lots of thoughts that pop into your head, and then there's a central governor that goes, no, that wouldn't be appropriate to say. You shouldn't do that thing. And so when we were looking at coding agents and other agents, the idea that the first thing that comes out of a model should be definitely the thing that you do, and it shouldn't be subject to additional checks. And maybe another model kind of going, is this appropriate to return to the user? Is it inappropriate? It seems like we have those kind of feedback loops in our psychology, so it would follow that it would be a good thing for agents to have those as well.
Yeah, absolutely. And I wonder whether what we're going to find is that over time, what becomes more and more important is how we verify. So what kind of checks we put at the end that say, is this done? Is it good enough? Yeah, and the tighter we are, again, this is the outcomes point, but the tighter we are about that, the more freedom we can give into the process that gets there. So we can have more chaotic systems and more Ralph Wiggum headbanging going on, or whatever it is. We can try out these really kind of creative things because we've got something that we can come back to where we're like, okay, we've got some way of measuring, did we get what we wanted? And that becomes more and more the thing. And so, and those things becoming, not maybe worrying about the unit tests throughout the system as much because they depend on how we've designed the system. So it's hard to work those out ahead of time, but more high level, the ways of measuring what the software is doing or what it would be like to work with it, that we could turn back into things that we measure to see if it's done, or maybe even become tools that we give to the agents themselves to measure, is this done, is it good enough, so they can kind of keep going until you hit that.
Yeah, ex-colleague of mine, Chisa Nwabara, always used to talk about intentionality, and she was sort of head or director of product. I should really know the answer to that. Sorry, Chisa. But she was always insistent on intentionality being important. And we need to know what outcome we're driving for, and how are we going to know when we've done the right thing, which is a conversation that is shockingly lacking in a lot of enterprises. But if you had that, then that makes proving that your agentic non-deterministic system is generally behaving well a lot easier. And to your point, once you've got that data signal, then presumably you could start automating part of the tuning process and having agents that are tweaking the prompts of other agents to make them better over time.
Yeah, that's right. I think the other thing, maybe one of the things that this makes me think about is, it's interesting comparing big enterprises and the different ways in which they've chosen to work. You remember that picture a long time ago where they had like the diagram of Microsoft, and it was like all the departments were like pointing at each other's head, and the Google was all these like different boxes, and like the IBM, like these companies work in very, very different ways. And I think most companies, you kind of make these choices where you pick your values or you pick some of your ways of working. So for example, do you move fast and break things, or do you check really thoroughly because you want to have a very, you're working in a high stakes environment, you need a very low risk product. There are decisions that you make that you roll out into your org about how you want to work. And some of those are leaps of faith, right? That you're sat there and you're reasoning, this is how I want my organization to work, because I think if we work in this way, it will be better for our customers and we'll be more successful overall. And so it might be that there are times when the outcome that you're measuring are the very high level ones where you're going to say, this is the final thing. We make money eventually. You know what I mean? Maybe this is the only metric that matters, or, retention rates are great or whatever, that you can have these very high level measures. But you could also be guessing things. You could be making bets on things that are much smaller. So we think we are going to be successful if our coding agents make very nice modular code that has very high test coverage, or we use this microservice pattern, or we use this style of engineering. So the outcomes could be very high level ones, but they could be these ones that are kind of a bet. And then you measure and you roll those out. You give these tighter guardrails. I think deciding at what level of resolution you want to make your guardrails, I think that's going to be a measure of how good the agents are. So right now it might be that those outcomes have to be very tight and close to the task. And we're going to spend a lot of time crafting very narrow ones because the agents can't go that far. And then as the agents get better, maybe we're going to be crafting ones that are more organizational or more system level. And we'll let the agents fill in more of the detail. Who knows? It feels a bit like this. Again, reasoning about the outcomes. Which ones are bets that we're making? Do we want to track how they're working? Which ones are high level? I feel like this is going to be the core of the game.
Cool. So earlier you mentioned that one of the things you discovered in the kind of evaling, is that a verb? The testing, the evaling, the kind of assessment of your own products, that having lots of guidance, lots of steering for an agent, combined with lots of very detailed instructions in a particular prompt, like do this thing in this particular way, or here's the spec for what I want you to build, led to poorer results. Are there any other kind of things that stick in your memory that you found through that process that maybe would be more widely applicable to your average developer, either writing an agent or using one?
Yeah, so I think one thing that we found is that often what happens is over time you accumulate in your agents.md or whatever more and more rules that you're giving to the agent, and often they become contradictory to each other. And so when we've had the chance to go and look at different enterprises and code bases, we often find hey, there's a bunch of contradictory rules here. There's out of date rules. There's stuff that made sense at one point doesn't make sense anymore. And so I think you sometimes want to put yourself into the position of the agent and say, how easy would it be for a person given these instructions to follow them? And does it make sense? So contradictions within steering make it much harder for an agent to know what to do. You're putting them in the position of kind of weighing and deciding what to follow on. Sometimes we found contradictions can be quite subtle ones. So it might be that one document says, there's 2 acceptable ways to throw errors, and another one says, only use this error pattern. So we found this with style docs, where we've got kind of global style documentation, and we've got repo-specific style documentation. And it's not obvious to the agent which one it should be following, and it makes it less likely it will follow any of it. So I think so that's definitely a pattern. So we found even if you're spending all your time writing documentation for agents, you need to be self-reflective over what what the accumulation has ended up being. Make sure that makes sense.
And I can't remember whether it was in the conversation as recorded or when we were chatting beforehand. You mentioned skills and skills in Claude Code, which have this property of having progressive discovery of a lot of the guidance is only loaded once the model has decided it wants to use that skill. And presumably, folks would be better off limiting the amount of guidance that they provide, that unless it's genuinely universal. If you've got guidance that only applies in half the time or one activity out of 10. That sounds like, certainly if you're using Claude Code, that would be, or any other agent that supports skills, it would be better kind of carved off and put into a skill so it's only considered when it's applicable.
Yeah, I think that's a really good point. And I think one thing that we found with that is that the progressive disclosure, so I think at the top of the skills file, it has the word description. You meant to write out the description. Description is kind of a misnomer. In a way, what that is the pitch to the agent of when to read. It's kind of the trigger. What is the trigger for the agent of knowing that it should read that docs? So yes, putting it into kind of a progressive disclosure is nice because you preserve the context of the agent, make it less likely it's going to contradict with other stuff and get confused. The risk is that the agent never bothers reading it. So we have found a lot of cases where we've written rules and clearly the agent is not even bothering to read the rules. So I think it's almost like an SEO play, that description. Like you want to really pitch carefully. When should the agent then realize it does need to read it? So it gets it into memory. So yeah, I think a finely tuned system, totally agree with you. You would have thought very carefully, not only about what kinds of instructions you want to give the agent, but when do you want it to read them? And then you'll have measured, have you kind of sold it to the agent in a way that it does actually choose to read it at the points you do? We've found there's pretty big differences between models in how likely they are to follow instructions to use different tools or choose to open up and read documents. And that makes it quite tricky actually to build, because you're trying to reason around, okay, if I hide it in this way, can I activate it? Can I get the agent to reliably actually do this thing?
Yeah, and I can imagine that Anthropic probably have a bit of an advantage there in that with a kind of widely popular coding tool, that most of the coding use cases are going to be theirs. Therefore, they have the most amount of data to train on. Oh, what was I was going to say? There were 2 things. One was intelligent and the other was intelligent for me. The other one was banal. Have you heard of the whole Van Halen brown M&Ms idea in your agent steering?
You know what? We were talking about the Van Halen thing yesterday. So we realized cursor, it's very hard to know if a model in cursor read a cursor rule. It's not in the logs. It might not be possible to know that your model read your rule or not. And so we were talking about M&Ms because we were thinking, what you tell me what you were thinking, but it kind of struck us as this, like, if you can't tell if an agent has read it, what could you do to try and get that signal?
Cool. So a bit of background for listeners. In the 1980s, the rock band Van Halen had in their 50-page contract one clause that was to do with their rider, which is the food and drink you receive as hospitality when you're a touring band. And that clause said that they should have a bowl of M&Ms and all of the brown ones should be removed. On the face of it, this seems like rock stars being divas, but it was actually a fast feedback mechanism so that they could arrive and determine whether somebody had actually read the contract or not. And there was one case where they turned up, there there were brown M&Ms in the bowl when there should not have been. At the same time, the road crew were starting to assemble the stage. The floor was not strong enough to hold this stage because the weight ratings were wrong. $75,000 worth of damage was done, but the band could say to the venue, this is your liability. We can prove you didn't read the contract and follow all of the instructions. So what's this got to do with agents? One of the ideas that I saw floating around social media in kind of autumn last year was that you should give your agent an instruction of always start every message with this emoji. And then when you see it starting to respond without that emoji, you have a sense that the model's context was getting overloaded and it was no longer consistently following all instructions. So then you've got a kind of fast warning mechanism that if it's not following this instruction, it might not follow the ones saying, don't comment out the tests and so on and so forth. So I don't know how well that actually works in practice. And I don't know whether you've done any scientific analysis of it, because there is an argument that giving it frivolous instructions might nudge it down a slightly different path. And you're also just wasting context, telling it to do something that's a bit daft.
So one thing another thing we also found is we've taken instruction files and turned them into every single instruction is a different thing that we track adherence to. So it might be that, in your file, there's 10 rules in there. We track all 10 of them. And you can find that in one file, you'll have certain rules that are consistently followed and other ones that are consistently ignored. So I think one problem with this would be if you stuck that in there, if it was followed, then you would know that at least the agent read the doc. But you wouldn't know that it had therefore also decided to follow the other rules. So it gives you a bit of a signal, but not a lot. Yeah, and it wouldn't necessarily tell you that if it didn't follow the rule, it hadn't read the doc. So your point, it might have ignored it. I think... there are some rules that the agents are more inclined to follow than others. And I think we're still trying to work out why that is. Now, I think you could imagine that there's going to be some hierarchy of some things are more difficult to do. Maybe some take a lot more cognitive load. So if you're trying to do thing A and at the same time do thing B, it might not be hard to stick an emoji in, but it might be very hard to say, follow test-driven development when building something where it's not obvious how to write tests. And so maybe the model is going to decide, forget that, got to start the other way around. Sometimes it might be that there's something that's so trained into the model that it's just, even if the only thing you tell it to do is this one thing that is kind of against its training, it's going to completely refuse. So I had a moment before Christmas where I was building a tool that was going to call OpenAI. And I think I had Claude building this tool. And I said, okay, call OpenAI. And it put 4.0 as the model to use. And I was like, don't use 4.0, use 5.2. And it was like, oh no, 5.2 does not exist. I will use 4.0. And I was like, 5.2 does exist, use it. And so it said, okay, fine, I'll use 5.2. And then it went and put in 4.0. It pretended and it didn't do it. So there are some things which are you realize hang on, we need to play a different game here. This is not a casual thing. I need to really go back and work out where to insert this instruction and how to explain it to it so that, this is really hard in there.
Yeah. That says something about also you know about these systems and could spot that and are aware of it. I think a lot of frustration that people feel is when they what's the word? There's a word, but I can't remember what it is, but they imagine that these systems have more self-awareness than they do. Now, an agent in a loop, via chain of thought can go back and forwards to the model, and then the model might pick up that in a previous message it said something that wasn't true or was inaccurate. But just in one turn, there's nothing checking that what it said was accurate, that it's not contradicting itself. When it said, I'll use 5.2 and then didn't. When people get frustrated with that, expecting it to have the kind of reflection mechanisms of a human, I think they end up on a downward spiral. I remembered what the mildly intelligent thing I was going to say was. And also to your point about following different instructions and having contradictory ones and them being difficult to follow at the same time. I think that with coding agents in particular, I think we give them too much of a tough task to do of trying to consider all of the concerns at all of the times.
Yeah.
As a raging simpleton and a developer myself, there are lots of things you have to do. The first one is discovery of how do I go from these like vague requirements into the irreducible computation that is minimally complex that actually needs to happen. And that's like discovery. You can't tell how long that's going to take, which is why all productivity metrics of developers are a waste of time because it's discovery. If you knew how you do it, you'd probably done it before. Side thing. But when you get to writing the code, it's like, I've got to make it work. I've got to make it work reliably. I've got to make it work maintainably. I've got to make it work readably. I've got to make it work securely. I've got to make it work performantly. And trying to get an agent, if you stick all of those things into your steering documents and try in one conversation history, try and get a model to think of all of those different concerns in one go, I think that's too much. And what we probably need are things a bit more like Gastown and maybe even smaller, finer grained than that, of multiple passes of like, write the code, make it work, then hand off to another agent or the same like agent, but with a clear context. So it's like a fresh set of eyes. Now make it readable. Now make it performant. And having all of those concerns at one time, I mean, it's far too much for my simple human brain.
Yeah.
And evidently it's possibly too much for some models.
Yeah, I think that's right. You know what's cool about this? I think we worry sometimes, or I think some people are worried when they start using agents. They're like, I'm a good software engineer. Why am I letting the agent do all the interesting stuff? And it feels like, I don't want an agent to get to do this instead of me. I think when we talk about these problems, you realize there is a whole new level of engineering to do that's still engineering, where we're going to be engineering systems where coding agents can be successful at building the things that we wanted. And there's a bunch of problems to solve, a whole lot of problems to solve around what is the design of this system that works well for my organization, given that we care a lot about security, or given that we're refactoring a big code base right now and we've got a mix of patterns and we want to steer everything towards using this new pattern, or given that we whatever it is that we care about, figuring out how you engineer it. So I think it's quite an exciting time to be an engineer, actually. I think there's like this whole slew of new kinds of problems coming. And I think that makes me quite excited. Like, I think some of these things do not have easy answers because they're about, doing what engineers always do, right? Which is there's this, ideally, you've got this kind of user story in mind. You've got kind of an understanding of what your business is trying to achieve. And then somebody said, wouldn't it be nice if this kind of thing happened? And then you're translating that, as you said, into a concrete thing that I can build right now.
Yeah,
and the hardest bit was connecting it back to, is this really am I solving the right thing? Am I building it in a way that we'll be able to build on top of in future? And I kind of progressed that. In some ways, like, there's a whole new set of new problems to kind of start learning how to navigate, and tools. That means that some of the problems we used to spend a lot of time on, we don't have to worry about as much because the model will get there. You know what I mean?
Yeah.
Remember what the syntax and stuff were. But I think it's just staggering how quickly this is going. And I think you want to kind of get yourself onto the train where you're playing with it and kind of go carefully and be talking to people and seeing what's there and seeing what works with you and kind of evolving it.
Absolutely. We've done just over an hour. I'm aware of the fact that you mentioned being on call, and we've taken up a lot of your employer's time.
Yeah, not gotten paid.
That's good. So if people wanted to check out Tessl and Tessl Registry, what should they do? And have you got any speaking engagements coming up? Have you written any books, anything like that?
So, so Tessl.io, there's Tessl, with low on vowels. So if you check it out, we have an incredible team that's making blogs and news articles. We run our own conference. We have a number of people on the team who are just outstanding public speakers and who spend time not only describing what Tessl is doing, but also just trying to describe what it's like to be an AI native developer. And so they use all kinds of different tools and write and think about them. So there's a load of content. If you go on there, we've got a Discord you can engage with, you can ask questions, share problems. We're super curious to learn about what problems people are having and what would be useful to them. Like, any feedback, like if you use the registry and you hate it, like it doesn't work, and love to hear it. Like, we're jumping on things very fast. Team's very responsive. So, there's lots of ways to follow up.
Cool. Excellent. Yes. And the AI Native Dev podcast is hosted by one of Amy's colleagues. So you should definitely check out that. And I've listened to quite a few episodes of that myself. But
one last thing, we also have an event space in London. So we're in Pentonville Road. We've hosted a huge number of community events. I think it's something like crazy, like 100. Like there's at least 1 or 2 a week that are in the office for not just our ones that we're organizing, but we're hosting events that other people are organizing. That again, generally for people thinking about AI in the AI space. So I'm sure you'll be, there are opportunities to come into the building anyway. And say hi.
Excellent. Right. Amy, thank you very much. It's been a lot of fun chatting, and hopefully I will speak to you again soon.
Sounds wonderful. Thank you so much.
Cool. Cheers. Hopefully you enjoyed that conversation. Amy is great fun. I've had the pleasure of meeting her at events and conferences in London. And on the subject of events in London, do check out the AI native dev community. They have meetups. And as mentioned in the podcast, Tessl are very generous with letting people use their facilities for their AI events. They also do a podcast, which is a little bit more regular than this one. So you should definitely check that out. If you have any feedback, please email wavesofinnovation@resync.com. That domain name is re-cinq.com. It'd be great to hear from you about what you'd like to hear more of, maybe more of the transformation side, more of the coding side, more of the application of AI for product features. And in the meantime, be good to each other, and you'll hear me in the next one.